Make sure. Yeah. All right, so these next few kind of all go together. This will look more similar to what we had done in pre-cal last year as far as like finding the power function and behavior model. So that's like the highest powered term or looking at the highest powered term top and bottom to determine like what's happening. And then if there's a horizontal asymptote, we're stating that as well. That's like the two parts to this. So 40, f of x is equal to negative 4x cubed plus x squared minus 2x minus 1. So obviously this one's not a fraction, so all I care about is this piece right here. And so when I want my power function, all I'm doing is just whatever the number is with the variable. I just literally just write it down. And then horizontal asymptotes, well, it can only have a horizontal asymptote if it's like a fraction or, well, that's the only situation we have right now is if it's a fraction. So I would just put none for horizontal asymptote. Because technically, I guess you could argue this is a fraction over 1, so bigger on top, but it doesn't really matter. 42, f of x equals 3x squared minus x plus 5 over x squared minus 4. So I just care about this part here. So my power function, well, they would reduce because it's technically 3x squared over x squared, but that would reduce to 3. So my power function is just 3. Do you know what the horizontal asymptote would be?
3.
Yeah, y equals 3. Um, 44. F of x equals negative x to the 4th plus 2x squared plus x minus 3 over x squared minus 4. I always feel like when I'm doing this, it's so pointless to write out like the entire thing because you don't care about any of it but the first part, but so I'm looking at the negative x to the 4th over x squared. So that reduces down just to negative x squared. Do I have any horizontal asymptotes on this one? No. It's bigger on top. All right, the next couple of problems say to find a simple basic function as a right end behavior model and a simple basic function as a left end behavior model for the function. So these ones are kind of weird. You kind of have to put them in your calculator and look at the graph. But 46, y equals x squared plus e to the negative x. So I'm going to put that equation into y equals. I was going to say you might want to use Zoom Fit instead of Zoom Standard, but it kind of made it harder to see what was happening on this one. Okay, so basically when I'm determining left end behavior and right end behavior, typically, it doesn't always happen this way because we'll see it in the next example. But one of these pieces is going to be for right and one of these pieces is going to be for left. That's like given to us. So obviously the graph of x squared is a parabola. And this whole shape kind of looks like a parabola. But if you look at it, the left-hand side actually doesn't look identical to the right side. You have to look like pretty close to tell.
Oh, yeah.
But if that's why I said I was going to say zoom fit, but with zoom fit you can't see the whole graph, so it's weird. But basically it's going down like pretty quickly here as far as that goes, and then over here it's more rounded. So my left end behavior over here is going to be this e to the negative x because that's the exponential part of the graph. So I usually just do like LEB for left end behavior, is e to the negative x. Then the right hand side looks more like the x squared part, and so the right end behavior is x squared. So sometimes it's two different, like the pieces, it ends up like one of them is one and one of them's the other, but they can also be the same for both because of how the graph works. So if we looked at like 48, y equals x squared plus the sine of x. This one's going to be a little bit different if we type this one in. I don't remember if we have to do zoom standard or zoom trig because there's a trig function in here, so we may have to do it both ways to see. Zoom 6. I'm going to see what happens if I do zoom trig. Not really anything. All right, so basically, what do you note? Like, what do you see about like this graph?
The left side looks like it's going down faster.
Yeah, and then I see that it goes under here as well. I'm gonna see if I can like zoom box it and see what happens. That was option 1. Try to get in this focus area here. So it basically kind of looks like they've taken the parabola and almost shifted it, right? But we don't see any kind of like continuous whatever. So this one, even though the parabola is kind of funny shaped, it's almost like the sine of x has basically just shifted the graph a little bit. So this one is a weird one where both the left and the right end behavior are just x squared. Because sine's going to just be repeating, it's not going to like change anything really. So that's why it's still going to just be x squared on this one. If it's like a logarithm, it could also be the same thing. I mean, obviously you just kind of have to look at the graph and see, but this one just happens to be that they're both the same. I don't think I normally put this on like the quiz or the test. I just like you to see it. It doesn't really come up again on the AP exam either. It's just so that you can kind of see like what's happening as we're getting really, really far out of this graph. And part of that is because also if I went as x goes to like infinity, sine's just hanging around, right? What everything else is. It's just affecting what everything else. Whereas with this one, if I put in the value, it's going to change it for like negative infinity versus positive infinity too, if you wanted to do it algebraically. All right, so the problems to go with this section: 1, 5, 9, 13, 15, 21, 27, 29, 39. There's a lot. got 41, 43, and then 45 is one of these in behavior ones, but again, I wouldn't stress about it too much, but just so that you've seen one. So, anyways.